Okay guys, another video here. I'm making the new splines, and what I decided is a couple things. First, I'm going to change the approach to actually cutting the splines out. So instead of cutting them out on the scroll saw, what I'm gonna do, or what I've already done, is ordered some smooth on, it's called a smooth on Mold Max fast set plastic. So the plan will be to complete the spline, draw it out, cut it out on the graph paper, and then take that cut out and create a clay. What I'll do is roll a slab and then cut that slab out so that I can pour my plastic in to create the rib. So basically, instead of cutting the rib, I'm gonna pour the rib. So that's one thing. This is the new spline. Very quickly, the math here, the angle 60 degrees, 55, 50, 55, 50, 45. Okay, 4 stages, 1 inch for the hub. Now, in terms of the electroplating, this is where things are starting to get a little bit more complicated. Electroplating this particular component, as opposed to the horns, it's a whole different challenge. You're going from a longitudinal electroplate with baskets, long baskets, 2-foot cylindrical baskets. This is a different setup. To electroform something with this sort of transverse profile is a different ball of wax, which I'll get into a little bit later. But I quickly want to go over some math here. So feel free to point out any discrepancies in my logic. But what I want to do is, what I'm trying to do, find a simple way to measure the surface area of the meandering membrane. So what I have done is measured each of these lines. So this is 1 inch, 1 1/4, 1 7/8 times 2, 1 3/4 times 2, 1 1/2 times 2, 1 1/4 times 2, 1 1 and 1 3/4. Sum all of those up. So what you can imagine is, imagine this is a string and you just pull it out straight. The radius of that string is now approximately 17.75 inches. So what I do is calculate the surface area of a disc. 17.75 squared times pi gives me a surface area of 989 square inches. So now, because my electroplating chart is in square decimeters, I could convert this to inches, but I have to, at some point I gotta probably just convert everything to inches. But what I'm gonna do now, take that 989 square inch surface area of the meandering membrane and convert it into square decimeters. So that math was wrong. So here's that math: 989 square inches, 1 decimeter equals 15.5 square inches. So 989 divided by 15.5 gives me 63.8 decimeters. Okay, so now I know how many decimeters surface area my part is. So now what I do is I go to my chart here, which shows me at a given current density, how much copper will be deposited over a given period of time. So working from the lowest current density of 0.5 amps per square decimeter, you deposit 6.65 microns per hour, and it takes 150 hours to deposit 1 millimeter. So 1 millimeter, a 16th of an inch is approximately 1.58 millimeters. An 1/8 of an inch is 3.175 millimeters. Okay, so say you double that to 300 hours to get an 1/8 of an inch, which is not, I'm gonna go under an 1/8 of an inch for my parts to fit into one another. So 0.5 amps per decimeter, I'm electroplating 63.8 decimeters, which is gonna mean I'm gonna need to apply 31.9 amps to the part, okay? So now I know at 31.9 amps and 150 hours, I will deposit I'll deposit 1 millimeter, which is under 1/16 of an inch. So probably 175 hours will give me a reasonable wall thickness for this part. Okay, so I worked through all that math there, kind of fumbled through it and figured it out eventually. Calculating the surface area. I feel that's a logical approach. It kind of makes sense. I mean, if you just calculate the surface area of a disc at 10 inches, you get a surface area of 314 square inches. But this, if you were to take like a sheet of paper or some kind of material that would deform, you would have to stretch that material in order to conform to this profile. So 3 times approximately, that makes sense to me. So about 1,000 square inch. And what you do is, what I've done here is taken 10 inches and increased the path to 17.75 inch. Okay, so that's what I'm doing here with the math stuff. And then I started I'm gonna lay out another idea. So I have about 6 layers of latex on the plaster negative again. But what I'm gonna do this time is something a little bit different. And I'll explain this, and then in future videos, next couple days, I'll kind of show you the end result. But what I'm gonna do is create the master, and the mother, the wax, is going to become my vessel, so to speak, my electroforming vessel. So the way I'll explain this is as follows. Finish the latex, and then put my caudal boards 1 inch offset from this plaster wall. Okay, I'll seal this up down here. I'll probably put clay to smooth up, like a slab of clay on the foot here, and then some keys, some indentations. Okay, and then I install the caudal boards around the model, giving myself an inch all the way around. And this inch from the plaster to the inner diameter of the caudal will become a wax wall with a flange, a keyed flange. So now the wax is set, I pull it out, flip it over, and then I will make a base form which will key into that flange. It will consist of wax and plastic, and it will be designed to accommodate the anode basket. So now I have a lid with a keyed flange, a wax lid with a keyed flange, the wax being the mother of the master mold, keyed flange, flip this, and then a disc-shaped lid, which will fit, let me work back there. I'm gonna flip this, and then I'm going to pour a disc that will key in to the base here. And then I will extract that wax base, and then I will flip the whole thing. Okay, so now what I have is basically a container where this is the lid, this is on top, and then my cathode is on top, and my anode is on the base of the form. So this will become the tank. I'll seal up the flange because it's wax. I can seal it up. Probably have a latex seal in there as well. Latex seal, wax seal, keyed flange. And my thinking is that I can fill that up with electrotyping solution, thereby drastically reducing the volume of electrotyping solution required to electrotype the form. So if you consider, if I put this in a 55-gallon drum, I've got 55 gallons of solution, right? I can cut the solution needed by maybe half, 3/4 with this technique. So this is what I'm working on right now, as well as the new ribs. I'm waiting on the plastic. I got 2 quarts of this fast set plastic, and then I'll pour the new ribs and get the ball rolling on creating the new plaster models, so that I can really start to piece this idea together. All right. So things are coming together. What do you think, Peppa? So just continuing on from that last segment there, where I'm explaining this new technique, the goal is to simplify this equation. So down in the basement, I can show you, I put together a tank for this specific part. And what I'll do is sort of show you, juxtapose the 2 different techniques. But with this technique, the idea would be that as you're creating your cathodic master, you're also building the electrotyping tank. And the tank will have a wax mother or shell, a lid section, which will be the cathode, and a base section, which will be the anode. I'm still kind of figuring out how to do that anode, how to make that anode. What else? Yeah, the idea would be to make almost like an electrotyping egg. So I'd seal the base to the lid, and then in the lid, I would have access for a small, I bought a 250th horsepower chemical circulation pump. It's just it's called a Little Giant chemical circulation pump with a 1/2-inch inlet and outlet. So what I'll use is that pump to circulate the fluids within this contained wax vessel. So I have some way of circulating. I have to figure out how to get my anode bus bar in there. How to sort of plumb it, because before I pour the wax, I like to have, all the plumbing in place. So basically I'll roughen the plumbing, roughen the electrical. Yeah, I come from construction, if you can't tell. So just continue this idea. I think maybe 5 or 6 more layers of latex, and then I'll roll out the slab of clay, put a nice smooth base here, keyed in base, take off this tape, install the coddle boards, and then when I pour the wax, I'll ensure the coddle is well sealed at the base as well. When I pour the wax, I'll pour this this wall first, and then I'll pour in the base, which is actually the top of the vessel. So really if you're inside the vessel, you're looking up at the underside of the lid. And the reason I'm doing it that way, if you did it the opposite way and you had the anode just floating above the cathode, it's the easier way. But the problem with that technique is the anode is gonna, even if you bag your anodes, they still drop sediment, and that leads to a rough surface texture. I can show you in a piece of pottery that I electroformed, how that surface texture, how the sort of copper deposition leads to a rougher surface texture. So that's the reason why I want the cathode to be the lid and the anode to be the base. The sort of logical Reason why you do that is because the anode is going to be quite heavy. So it makes sense for the anode to be in the base. What else? I think that's about it. I'll just keep working here. So if you look inside this bowl here, this is a ceramic bowl that I copper coated on the inside. It's quite dirty. Just give me a second, I'm gonna sit down here. So the inside of the bowl is quite rough. You can see copper smooth here and then it gets rough. So what I did here, I hung the anode in the bowl. Filled the bowl up, hung the anode inside. So the cathode is the bowl, the anode is hanging in the bowl. And the result is you get a copper coat, but I'm sure with some more effort this could be avoided. However, I think what I'm gonna do is make the anode the lid and the cathode the base. And in so doing, I get the most refined plate. At least that's what I think will happen. Okay, the other technique, let's get some light here, for electrotyping this part would be a shallower bath with an anode basket in the base, filtration pump, and then what I do is I take my piece, and because it's got wax, it will float. So maybe what I should do is just water test this, but the idea would be to take this and float it on top of the anode basket. I can change the proximity of the cathode to the anode by changing the volume of water, with the constraint that I can't reduce the volume of the tank any lower than an inch above this weep hole in the pump. So yeah, and the cathode will interfere with this outlet in the pump as well if I go any lower. Anyway, so this technique will work. I've done it this way, and I'm just gonna have to play around and figure things out, because this form and these baskets, these long anode baskets, these match, right? These anodes match this cathode. So really, like, what I need in a sort of ideal world, it would be really nice to have a flat cylindrical anode basket like this. I just sort of threw together with it's as much as you can do without knowing how to weld, and because I don't know how to weld, I can't create these things. However, I could buy all this material, cut it to size, get it all set up, and then hire a welder to put it together, or order these baskets. These baskets, brand new, are very expensive because they're titanium. So a custom anode basket for this is it's out of the question. And I can do as good a job using other techniques. And just to close things off here, these pulleys, got them welded. The welder is going to come back, going to build a bracket for the motor. So the motor is going to bolt to a bracket, which will be welded to the drum and to some feet on the bottom of the drum. You got your 6-inch pulley, your 12-inch pulley on your 1 1/4 inch shaft. There will be a metal lid with the bearing housing and bearing, and then your meandering membrane below the lid, the half egg shaped hub, and then your whorl pipes extending down into the drum, which I think what I'm gonna do is I'm gonna use red earthenware slip as it'll probably be the first thing I run in the machine. I have just this sort of feeling that's what I should do. So you get a sort of look from the inside. I will dry fit everything into this drum. This helps me just to visualize. Just a little kind of side thought here, because the upper membrane is going to have pressure chambers and the sort of, what do you call them? Meticulations in the, like slot meticulations, right? What you could do is on the top of the drum, this is a little bit, I won't do this now, but you could perforate the top of the drum and have a mechanism which opens and closes the vessel. So basically opens and closes the perforated holes, so you can allow air into the upper membrane. For what reason, I don't really know, other than I'm just kind of curious, you know, just curious. I don't know, I'm gonna have to put a drain cock in here somewhere, some kind of drainage system. There's a lot of other things to think about here. So many other things to think about. How do I install the bearing housing in the bearing in the base? I'm probably gonna have to get something welded down there, and then I can thread into whatever is welded down there and set the bearing housing into that. Because the thing is, I need some ability to align this shaft, so I can't just weld the bearing housings in place. They have to have some play in order to align everything. All right, I think that's pretty much it. So I'm not going to use the scroll saw to cut out the next set of ribs. I'm going to pour the ribs, because no matter what, even if I cut it out the best, absolute best I can on the scroll saw, I still have to sand. And I think the result from pouring the plastic into a sort of clay, inverted clay cookie cutter is going to result in smoother curves and a spline that is closer to my original. I get a lot further from the original going from paper to plastic and using a saw, because those saw blades, they just naturally kind of want to deflect, and it's hard to get the rounded curves on the rib. All right, so I'm gonna pour the ribs, continue with the welding. Hopefully that gets done this week. I'd like to set up the motor and the speed controller and the pulleys, get the belt, continue experimenting, building the new tank using wax as my shell. Wax is just, it's a beautiful thing. When it's thick enough, it's very strong. It's totally inert. It doesn't react to any of the acidity in the baths. It seals very well. And because these processes take place at around body temperature, you know, there's no risk of melting it. That being said, you know, the amount of current I'm applying to the anode is going to generate quite a bit of heat. And I have had some experiences in the past of burning things, melting things, etc. So obviously I gotta think about, you know, melting things, right? Like there was this one time, the hexagonal something, a metal piece melted right through that plastic there. But that usually only happens when something else has gone wrong, a connection has been broken, and the circuit is, when the circuit has been broken. So what I want to do is I want to find a sort of naturalesque way of electrotyping this, and I like the idea of containing the cathode and the anode within a wax shell that would seal up, and then you'd almost, you drain it and then sort of crack the egg to harvest your part. Now, whether or not the part pulls off of this smoothly, that's going to be another question. I think it will, because latex has it's forgiving and it has a good memory, right? So you can bend it, and it just has, it's very, very resilient. How well it will withstand multiple electrotyping processes, I don't know. I do know it's used as a resist in electrotyping, and I've used it in my baths before with no issues. So let's see how this goes. Play around with this idea. That's the other idea.